A set in its simplest form is a collection of distinct objects. Think of it as a container where you gather specific items. What makes a set unique is that each item within it is considered individual and unique. No duplicates are allowed. These elements can be anything: numbers, letters, symbols, even other sets. We use curly braces to denote a set and list its elements inside. When we talk about sets of real numbers, we're specifically looking at how the vast collection of real numbers, those that can be plotted on a number line, are categorized. This includes natural numbers, integers, rational numbers, and irrational numbers.
So today we're gonna see the concept of sets of operations, namely union sets, intersection of sets, difference of two or difference of sets, complement of sets, and Cartesian product.
In this question, I'll show an example of a union of sets. To find the unions of set A and B, we have to combine all unique elements from both sets into a single set. So in this question, we have a repetition of elements on both sets. We only have to include each distinct element in the union set. So our answer is 1, 2, 3, 4, 5, and 6, which represent all the unique elements in set A and B. So now I'll show you an example of intersection of sets. In intersection of sets, we have to identify the elements that are common in both set A and B. In this case, the elements that are common in set A and B are only 2 and 3.
Alright, on the third one, let's talk about the difference of two sets in algebra. Imagine we have two sets, set A, 1, 2, 3, 4, 5, and set B, 3, 4, 5, 6, 7. The difference of two sets means taking the elements that are in one set but not in the other. For example, the difference of A and B written as A minus B includes the elements that are in A but not in B. That means A minus B equals 1 and 2. Similarly, if we find B and A, B minus A, which is the elements in B but not in A, we get B minus A equals 6 and 7. This concept is useful in many areas of math and real life, like comparing survey results or filtering unique data. And that's the difference of two sets. Alright, and the next we're gonna have complement of sets. So let's consider a universal set is U and subset is A. Imagine you have a box containing numbers from 1 to 10. Now let's pick some numbers out of this box. Specifically 2, 4, 6, 8, 10. This smaller collection is called set A. But what about the numbers we didn't pick? Those remaining numbers are 1, 3, 5, 7, and 9. Form the complement of set A, which we called A or denoted A. In simple terms, the concept of a set contains everything that is not in the set, but still within the universal set. So, denoted A consists of all numbers from 1 to 10 except the ones in A. Alright, let's try understand the Cartesian product. Let's start with two sets. Set A is 1 and 2, and set B, A, B, and C. Now, the Cartesian product denoted as A times B is a set of all ordered pairs where the first element is from set A and the second element is from set B. So let's compute A times B. We take each element from set A and pair it with every element in set B. So therefore, the Cartesian product A times B is 1A, 1B, 1C, 2A, 2B, 2C. So that's it. The Cartesian product helps us systematically pair elements from two sets, which is useful in many areas of mathematics, including coordinate geometry and database operations.